All right, it is Dr. Ihrig here. Now we're going to talk about exponential functions. So we talked about linear functions being a straight line. We talked about quadratics being U's, smiley faces or sad faces. Exponential equations and functions kind of go slow, 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 fast. Or fast, 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 slow. And so that's what we're talking about. Now here is the formula that they give you on the formula sheet. A is what's called our constant. And you can see it right there. That's going to be kind of our starting point. And then the b of x is our base. And then the exponent will always be the x, and that'll always be in the exponent. You won't see the x like x squared or x cubed. The actual exponent is the x, hence the exponential equations. All right, so things to know about is if it goes up super fast, that's called growth. And honestly, that happens when our base value is greater than 1. If it goes down, that's when our base value is less than 1. So we could look right here and just go boom to boom to boom to boom to, is it growth, is it decay? Or let's just type it in. Instead of y equals, I'm going to type in f of x. So I've got 5. Notice how I had to put the 2 in parentheses, and the reason why we have to put the 2 in the parentheses is because we have to make that x be the exponent. Let's take a look at this graph. Notice here how this is a 5, and notice how it crosses the y-axis at 5. That's what I meant by the initial value. So whatever that number is outside that's the starting point, whatever the number is outside the parentheses. Then the 2 tells how fast it goes up or how slow it goes down or anything like that. So here we can see that that graph goes up. I'm going to move this a little bit. So this would be considered growth because it goes up. If I do number B, letter B, I'm going to change this to 100. And inside here I'll have 0.5. And by zooming out, I can see that 100 is where it crosses the y-axis. That's my starting point. And I can tell that it goes down. So because it goes down, that's decay. Let's look at one more. Here comes my 80. Inside my parentheses, I've got my 1.3. And again, look, it crosses at 80 because that's my initial point. And what does it do? It grows up. Just like my plants behind me, I'm growing strawberries. They grow up. It grows. All right, so again, anytime that the k value is bigger than 1, it's growth. Anytime it's less than 1, it's decay. And look what happens when it's exactly 1. It's just a straight line. That's it, because 1 times itself, and no matter how many times you multiply it by itself, is still 1. All right, see you for our next question.